Today we are looking again at the Isolate Explorer. Isolates have become, I don't say obsession, it's just there's a lot there and there's a lot of fun to be had with them. And there's incredible power in being able to offload tasks when needed, expensive tasks, to keep the app moving smoothly. So I think it's a good place to spend time, and it's all about Matrix in the end. So I get to talk about that. I also get to what is Matrix? Matrix is the super duper state manager I've been using for 25 years on all sorts of fancy things, including an algebra tutorial. I've now used it to wrap Flutter, and how did I do that? I don't write Dart. I write Clojure, and Clojure Dart is a wonderful implementation that is the Flutter world can now experience a Lisp-like language, very nice Lisp-like language that compiles to Dart, so it's the real deal, and really no compromises. Very, very efficient compilation. Great work by Christophe and Baptiste, and then the Matrix State Manager. So it's quite an interesting novel package, I guess, for many. Very few are familiar with the Matrix State Manager, and this is what Clojure Dart looks like when applied to Flutter. Some of these things, like what is that? These are just macros. This is the beauty of Clojure and Lisp is the macros. I can very quickly write up a little template and one for even row, one for abstraction, just to hide all this noise, which we don't really need to see when looking at a watch of code. We'd rather be able to see the application rather than the wiring necessary to get the effects we like. But we don't like mysteries, so here's even row. Well, here's even row. But there'll be some mysteries we'll see, and there are a few, maybe a dozen little macros that I use left and right that do things like navigate throughout the application to find data and then read that data and change that data. So and once you learn a dozen things, you are now the most powerful programmer on the face of the earth. Well, that's what my mom says. So rest in peace. Where are we here? Oh, so this is the Isolate Explorer. Let's look at the application itself in brief. So here it is. I started up the app. It starts. I have it now set up to start unpaused, so it is running. I can ping it. Ping, ponged immediately. Oh, there you get it. This is Isolates, and Flutter is so cool. Yeah, I can ping immediately. I can ping before next event. The difference, I don't know yet, but I guess that'll come eventually. I'm not going to exit or throw, but I could, and that would test the on error handler and the on exit handler. I've got a spawned isolate just sitting there waiting for some action. Let's have it decide if 9,039,000 is a prime number. Since it's divisible by 3, the answer is no. By the way, you can see some messages coming out here. They'll be handy later. That was pretty quick, right? But the algorithm is actually deadly slow. And doing 9,041,000, well, let's see how long it takes. Well, let's just do it. Boom. Okay, that was about 2 seconds. Now let's do that again. And this time we'll do the quick one. Now keep an eye on the sweep second hand, which actually takes 32 seconds to go around, not 60. But let's keep an eye on that and calculate that very long running prime decision. Didn't blink, right? Okay, so that's the power of isolates. It's getting offloaded to different hardware. Gets its own little EC2 instance, if you will, and does a quick calculation. Now let's do it in main. So we're not going to use an isolate, and that still goes pretty quickly. 9 million is divisible by 3. Now watch this and keep an eye on the second hand. Bam. Okay, so that's the problem. Doing that calculation in main was a killer, but the other guys were using isolates. Well, yeah, that was using isolates. Well, those were isolates. That was using the spawned isolate. Let's try it on Flutter Compute, Foundation Compute. Pretty fast. Pretty well. It's no faster, but all these guys take a couple seconds. But if we do it again, let's bounce over here and bounce back and watch that sweep second hand. No problem. Okay, so because that is, and I'm saying it's using Foundation Compute, and you say, Kenny, what happened to isolates? Foundation Compute will use an isolate on those platforms that have isolates, and I don't know if that includes the desktop. That's another. Let's make a note of all the questions I have to research after this video. It's such a big thing, this isolate, that I kept coming up with more and more questions, creating more and more buttons, being able to test more and more things. For example, I finally broke down, compute does the equivalent of ISO run. I said, oh, let's throw in a couple of buttons for run. So ISO run, it's a one-off deal. It spawns an isolate, uses it, computes the answer, gives me the answer, throws away the isolate, and then gives me the answer. So let's watch that. Boom. Quick, of course. And this again will be quick. Well, not quick, but the second hand won't bleep. Still smoothing. And now we get the answer. So so that's great. That's oh, we did pinging. I did pinging, I think. Oh, my request exit? Let's do that, bam, request exit. Okay, we're toast. So let's bring that back up. And by the way, I'm showing the resumer over here. I did a lot of investigation on resuming and capabilities. It's a little bit confusing. Real quick, when you start up a isolate, not paused, in other words, just started up normally, you still get a resume capability built into the isolate. It's the property is something capacity, a resume capacity. I don't know. It's there. You just can't use it. You'd never be able to use it because if you do pause this running isolate, you get a new capacity. Well, let's do that. Let's pause. And did you see the resume? Now we have a new resumer. Let's resume. And I'm going to consume that resumer, and it's no longer usable. And so anyway, if you look at the code, if you're interested in isolates, just check out all the code here. And hey, if you come up with some ideas, let me know, and I'll extend the Isolate Explorer. All right, let's get on with the show. So what is the show? The show, if you've been paying attention, well, I don't know. Okay. We'll do this guy. Boom, it says it's not prime, and now we'll do this one. Now watch what happens here, and here's the problem. I'm going to click the button. This message is going to still be sitting here. Ooh, that's awful. So we got a request from management to clear the announcement result line while working on a new result. Okay, so, well, how are we going to do that? So one of the nice things about Flutter is that one thing about Matrix is that you always know where to look because it is declarative. It has that much in common with React.js, which has and any framework that has view functions. So here's the view function for the result display, and you say, oh wow, it's pulling in properties from a property named worker result. Well, where is it getting that property? MAV. This is interesting. This is kind of crazy. There's the help message. Search strictly up for the first appearance of prop name and return its value. In other words, I don't even know where I'm going to find the worker result. I got a pretty good idea since I wrote this app that there's only one property worker result. So that lets us be extremely terse because otherwise, again, you can get this explosion of boilerplate where I go out and find the widget named worker result and then get the property value. You're not adding anything to my understanding as I look at the code if I have to read through all that. But if I say, go find the worker result, I say, I know that there's only one worker result, and it's above me. MA is ascending, and there it is. So I don't need to write any more noise than that. So I'm displaying that value, and we're looking at the message type. And so what do I got to do here? I want to clear and this is declarative. It's going to calculate a new text for a new string for the text, and do an automatic set state behind the scenes, and trigger the redraw. So what I really need, I guess what I need to do, and this is the fun part of programming with any, I suppose, reactive declarative engine, is you just sort of make things up and think about dominoes tripping over each other. And so what I'm gonna do is have this guy ready. If the message type clear comes through, I'm gonna change to the string clear. Why not spaces? Kids, when for you young developers out there following along at home, let's start with this so I know that it's working. Because if it's just nothing there, it could be nothing there for a different reason. So let's make sure we can announce clear, and then later we'll just change that back to spaces or ... or whatever. So now we have worker result display is now ready for a message of clear. So, well, hey, here we are. This is the run guy that I've been doing down here. Let's, wow, is that easy? Let's also mset. This is the destructive, mutating. Actually, this is one place I don't say, and we'll probably get there. Yeah, worker result was right on the app, and we'll get around to making that a little bit fancier as we go, because it really shouldn't be on the app. But got to remember, this thing was just knocked off as a hack just to explore isolates, and it kind of lived on, had a life of its own, and it's been a lot of fun. So now, bam, I've been talking, so who knows what I did. And let's go down here and press in, okay, and now we're going to do this guy, ISO run, clear. Oh, beautiful. Okay, so that worked. Now what we want to do is say, well, okay, that was nice, but let's make this into a macro, because again, it's if it has to change, it's all in one place. Yeah, let's put it right here with the result. I'm not going to worry too much about these. What did I say? What do I call result clear? And this is the beauty of macros, is I don't even have to pass in me or self or anything like that, because FASC will be looking for the lexical variable me, and it will find it, because this code expands into this code, and Dart CP provides the lexical me. It's, I guess, a little bit frustrating to look at this code, but this is a very small universe of magic. So there are a dozen, 24 bits of magic to learn, and then you are free and empowered and ready to roll. So well, let's see if it still works. All right. And, okay, so bam, and bam, still works. Okay, now this guy does his thing and doesn't do his thing. So why? Because we have to propagate result clear some other places. And I think there are about 4. And, there would be nice, let's think about this one here. On press, okay, well, I guess we'll put it here. Now this is a funny one, by the way. Instead of just doing the computation, well, this guy actually takes the n and he sets a run job, which is a property someplace else, and the runner, the bit of code that runs a isolate immediately, that guy is watching the property run job. So that's how this is going to work. And notice that I don't have to write any other code. I just say run job is n. Elsewhere, just as the result display is waiting for messages to come through, there's a job runner out there that is waiting for run jobs to come through. Am I talking too much? Let's see. Result clear. I put a result clear on the compute. So now compute. Did I save? Whoa. Well, let's save. Switching to the sim will save, but it's a little bit, it won't happen right away. So I might as well save, give it time, so by the time I get to the sim, it's cooking. And we could almost at this point get rid of that stupid clear word in main. Okay, well, should be the same thing, and let's do it in spawn. Same thing. And notice that, again, this is different. This guy starts the job by sending the job to the port of the spawned isolate. So we have actually a few different ways that things get kicked off, and this, as I said, it's just because I've been rolling this as I go, not really with any master plan in mind. Okay, so we should have both the spawn working. Okay, so you come up with not prime, and you come up with clear. Boom, answer. And now we go main. Main says not prime, and then we go main. Uh-oh, trouble. Well, fortunately, as a longtime veteran UI programmer who has seen many different UIs in his life, let's look at the main guy. What is the main guy doing? To be honest, I think main might have been the one I did first. And there was I could see trace output, and I debugged it. I won't bore you with that, but I confirmed that this was actually running, and the text guy, the result display was indeed seeing the clear message come through. And what I knew was sometimes with these frameworks, you got to tell it to kick the refresh out the door before carrying on. And that's what this is, because this is running in main. This, the other guys are doing things with where the event handler gets to jump in, the event loop gets to jump in and take care of, oh, he said display that text. In this case, this command here, macro, will kick off whatever it takes to get the guy to clear his message, and then immediately dives into running the computation, which takes a couple of seconds. And apparently the event loop never gets to fire. Well, so I went and Googled frames and dispatches and all sorts of things, in Flutter, and I came up with this. And I'm going to be honest, I don't know if it's going to work, because earlier today it was not working. So I'm going to, and you never know. But, well, yeah, let's see. I mean, I keep an open mind. Okay, I've been talking. And now what I'm doing is I'm saying I'm going to kick that off. I want you to do that. I've done a set state on that. And this is going to queue up the next step in a callback to be executed sometime later in the frame. Now, being in the post frame, I'm sorry, it's not in the frame, it's post frame. Some of the doc says at the end of the frame. Ouch. Don't, documentation is so hard to write. I can't do it. Anyway, it's not at the end of the frame, it's after the end of the frame. What a distinction. But, well, let's see. Because I'm dying to see if it works. All right. Oh, boy, I just finished. Oh, okay. So it's still working. So there must have been a glitch. No, there must have been, anyway, so it's been working consistently since then. So great. So now I didn't need to do the post frame callback on the other ones because they themselves were giving up control to the event loop. So now we have successfully completed our ticket where, guess what we can do now? We can make this into ... Okay. But this was good. I think I originally did this not just because it was cosmetically unsatisfying, but because I couldn't really tell what was going on when I did this. When I said, okay, ISO run, okay, and it ran, okay, and then I did this. Oh, so before the message would sit there and look as if it had run. But what I just found out was my clear ran, but something else did not run. Now, when you do the same thing twice in a reactive system, twice in a row, and nothing happens the second time, you know that there is a state management thing going on, because all these state management tools do the same thing. They do not propagate unless something changes. It's an efficiency thing, and it's absolutely necessary if you're going to have a reactive system, because I guarantee you, I've actually walked through this. If you let it recalculate everything every time, even when they don't change, it just doesn't work. So you need the efficiency of tracking what needs to be changed. Although if you look at React, their approach was to do VDOM, which is render everything, because we can't be bothered to figure out what changed. It wasn't that hard. I think MobX did a great job of that. I think Binding Scholar did a great job of that. And React should have done the same thing. But they didn't, and they gave us Flux instead and all of boilerplate. So, wow. Be careful. When you hear something is reactive, you don't know anything yet. Find out, is it granular? Is it property by property? Or does it do a whole view function where you look at one view function and it's got 8 dependencies, and why each dependency is needed for what, who knows. So with Matrix, what we're going to see is that it's all property to property. So why am I babbling about that? Oh, well, we just saw that we have a problem. And we know the problem is that well, let's look at the run aloud. What do? We set the, is run aloud. That's not our problem. Let's see, where do we do in run? We set the run job to n. All right, let's see where that's being used. Run job, mget. Well, that's here. The runner. Okay, I happen to remember the runner. So the runner is the one that uses the run job. And what we can do is make this ephemeral. Now you might say, Ken, you've never said anything about ephemeral. I might have mentioned it, but what a great word, right? Fleeting, evanescent. It is. I mean, it really is. When the run job takes on a value, it really will take on the value long enough to propagate, long enough for all the watch functions to run, and then it will cease to exist. Not in a reactive sense. In other words, you won't see, if you have something depending on run job, you'll get kicked off when it goes to 9 or 9 million. But when the engine resets to nil, no one gets kicked off. That's an internal resetting of the value. But as long as anyone, that whole propagation sweep from the change, it's going to get seen by anybody that runs, whether it's a direct dependent or an indirect dependent that gets kicked off and kicked off and kicked off. They're all going to see run job 9,000,039 or 9,000,041. So we're going to make it ephemeral and save. And let's see how we do here. Compute. We're going to say run. We're doing the runs. We're not doing, okay, I got to be careful. All right, so runs. All right. Okay, so that's great. It's running, but what's wrong? Why are we seeing nil? I know the answer. Don't worry. Where? Oh, so. Well, it's setting the worker result, and it's setting it to the run job, which should be 9,000,039 or 9,000,041. But here's the thing, with CC, this means when this change is over with. By the way, you're not allowed to change anything in a watch, but you can enqueue the change to be run as soon as the current change that's being watched has finished propagating everywhere. And when that is done, then it will kick off this next enqueued state change. So the problem is that, as I just advertised, because it's ephemeral, the engine has already reset it to nil. By the time this guy runs, it's not there anymore. And I couldn't actually think of a way to get that, and I made a mistake. I made a mistake. This is where I violated Tilton's law. I solved the wrong problem. The problem is not that it was ephemeral. Yeah, and I wrote the system. Oh my God. So what we're going to have to do is we're going to have, you know, the job is just, we're just sending 9 million over. It's just a number. And we're passing a number around, we're getting a result, but what we need is some really proper information in the job. So let's go back to where we create the job, and let's make it, all right, we're going to make it a message type. That's the wrong brace, dude. All right, message type. Decide prime. I'm doing this from memory. I think that's right. Decide prime. And n is n. Oh, you know what I'm doing? I'm going to... Oh, yeah. Down. I hate it when this happens. All right, the auto tabbing. This is ISO. The method is ISO run. I think we're using that already. Yeah, that's already. Oh wow. So well, that's interesting. I think that got injected by the runner. So let's see here. So now we're sending over a complete data structure. Decide prime, value n, method ISO run. So now when I get to the banner, all right, I'll be able to tell them what n is. So the runner is now new. So now our new is a proper data structure. Value. Oh, wow. So, actually, let's do this. Let's arrange for new to come back. Oh, I should talk about that a little bit. So this is the function that gets run in an isolate, and then the isolate gets discarded. So right here, and this is the answer that's going to come back, and it's going to end up being the value new. Maybe we should talk about that too. Prime decision will be ISO run, n was same as was new, and the value is just. I'm gonna have to check. I'm gonna have to check this. I'm typing and talking. Oh man. All right. So that's gonna go, and that's and new and oh. All right. So actually, job is what the job is gonna be, and then we're gonna say end job. Oh, come on. Be a guy. Let's see, keys. And as job. All right. I almost don't need. Yeah. All right. So I don't. Although, actually I could have. Yeah. All right. If this works, it's a miracle. Okay, so that's the run. All right, well, let's just stop and check here. So I've run. Okay, yeah, run is okay. I didn't really need that, but this is important because the job is no longer n, and we're gonna get that. We're gonna compute that, and we're gonna take all this, and that's actually just gonna go flying right into the worker result. All right, let's see what happens here. is not prime. It is prime. Who is he? Okay, so booyah. All right. So now, oh, can we do it twice in a row? So this is great, but we still have the same problem, which is that this map, or at least the map, the job itself, is still the same. The word is that same keyword, same number, same method, so it doesn't look like anything changed. So this, and this is, I warned you early on, I was going to get up on my soapbox about, we're going to create an artificial ID, a unique ID, and we're going to use, well, let me go find that. I'm sorry. This is a little bit lengthy. We need a timestamp. Milliseconds. All right. So where was I? Decide in run ID. All right. So now that's going to be different. And I think that'll do it, unless the message. I wonder. Because the result, so now the data we're sending through is going to be new, but is the result going to be different enough that, all right, so let's see here. Okay. So, wait a minute, I got to do it twice. Oh, okay. I was thinking that the result would come back differently, but the result would come back the same, and so it wouldn't fly. It would be on the backside where the the text went from being ... to being this. So yeah, that's a change. Okay, so all right, so that's good. So now we've solved that, and life is good, right? There aren't any problems. Oh yeah, watch this. 9,000,039 is not prime. Well, good for you. Let's check, and let's use the spawn to check 9,000,040. Oh, that is prime. Okay, and now let's turn off the. Oh, wait a minute. Let's go the other way. Turn off. Run it. Okay, it's not prime. Turn it off. Come back. Head for this guy. All right. Great. Now let's turn on the guy. Whoa. So did you see that? Like nobody asked you to run. Nobody asked you to run. All I did was toggle a checkbox. And hang on, we're almost done. And why did that happen? Now let's go look back at the runner. And you kind of might have figured it out. Where's the runner? The runner's up here. Let's look at this rule. The runner, and this is interesting, it's normally formulas are used for calculations, not to kick things off. But in this case, it actually works out pretty naturally. I guess this is getting to kind of an advanced level, or I'm not just computing a squared plus b squared. You know, I'm using this to know when to kick off something, and then I'm using a watch function to trap the result and pipe that back into the matrix, into other reactive properties. So it's checking this, so it has a dependency on that, which means that when I turned it on, the rule fired. Now, that's something to understand about matrix, is that yes, we have the granularity, but it doesn't look inside. It doesn't look inside my formula and figure out, oh, he's just turning on the checkbox. He doesn't really want to run anything. No, it just runs the whole formula. And because I was going from off to on, that was the first time I did it. I went from on to off. Well, it was off, so it didn't run. But by going from off to on, it came in here, saw this, and that was true. So I went ahead and proceeded to run the job. So the trick of using a timestamp, sorry, no good. But the interesting thing is that now we can go back to ephemeral, which was the right situation, and I panicked and took it away from being ephemeral because I couldn't see the value n, and I had to decided to create a structure to pass the value n, which would have fixed the whole thing, but I didn't realize that. So, okay. So now, what was the sequence? Let's see. We want to run this guy. We want to turn it off. All right. Now we want to come back up here and run this guy. Okay. Now we come back in here and we turn it on. And nothing happens. Because now a good point might be that we should do a result clear. On toggling a checkbox? I don't think so. All right. So that, I think, is that. And that was a long video. But lots of hooks and turns in there. The big deal to understand is ephemeral, state management, and the fact that you cannot use a timestamp to fend off glitches. Now, by the way, you saw that going from true to false worked because false. If I actually had this condition after this condition, there also wouldn't have been a problem. So I kind of deliberately set it up. And this is artificial, but in the real world, you do have formulas that have 2 or 3 variables. So, and if you have something that is an event-like element, it has to be ephemeral so that it is not there when any other value gets kicked off and decides to run a formula. So that was it. Okay, I hope that was fun. That was a long road. Cheers.